All right, this is lesson 7, transformations of the polynomial functions. So our essential question is, how are symmetry and transformations represented in the graph and equation of a polynomial function? Here's our table of contents. Odd and even functions. So odd and even functions. A polynomial function p of x equals a sub n x to the nth power plus a sub n minus 1 times x to the n minus 1 power plus a sub 1 times x sub 1 plus a sub 0 is an even function if it is symmetric about the y-axis, and an odd function if it is symmetric about the origin. So other types of functions can also be classified as odd or even. For example, the function y equals the absolute value of x is an even function. So basically an even function, if I split it directly down the y-axis and I fold it in half across the y-axis and the two sides of the equation match up, it's an even function. And if I rotate it 180 degrees about the origin and it's the same graph, then it's an odd function. Okay. So for example, an even function, so usually they're your functions that have y to the second power or y to the fourth power or the sixth power, so they've got an even degree, are more likely to be even functions. Okay. So basically for all the points in this domain, if I have one point on one side of my y-axis, I also have to have the same point on the other side of my y-axis. So in this case, I have negative x, f of negative x is on the left side of my function, and on the right side of my function, I have x, f of x. So basically my y value is the same, but my x value goes from positive to negative or negative to positive. An odd function, again, is that rotation around the origin. So it's 180 degrees rotation. So for any point x, y, I will also have a point negative x, negative y on that rotation. So for example, if this were 1, 1, I would also have the point negative 1, negative 1 on my graph. And then you have functions that are neither. So these could be either even or odd degree functions, depending on what type of function it is and how many terms you have in that function. So a function that is neither even nor odd does not have that point. So if it's not even because there is no same y but negative x, and there's no negative x, negative y. Okay. So you can see that point x, f of x, negative x, f of negative x is over here. So that point is not on the function. And negative x, negative f of x is here. It's not on that function. So this is neither even nor odd. Identify even and odd functions from their graphs. Okay, so use the graph to classify the polynomial function. Is it even, odd, or neither? So if I have this graph here, okay, I'm going to ask myself, what happens when you reflect the graph across the y-axis? So if I folded it in half, would I have the same graph? In this case, no, it's a different graph, so the original graph is not even. What happens when you rotate the graph 180 degrees around the origin? In this case, I get the same graph, so this has to be an odd function. And you can check by plotting one point and seeing if it is on the graph. So I plotted 1.5, 0.5, and I waited to see if negative 1.5, negative 0.5 was also on the graph. It is. So this means it's an odd function. Okay. So for this graph, it's going to have an even degree. Okay. I want to know what happens when I reflect it across the y-axis. So again, if I take it right down the center and I just fold it in half, will it be the same graph? In this case, it is the same graph, so the graph is even. I can double check by finding one point on the graph and seeing if it has a matching point on the other side of the y-axis. In this case, it does. 2, 0 and negative 2, 0 are both on the graph. So looking at this graph, I'm going to look and see first, if I reflect it across the y-axis, is it the same graph? No, it is not it's not the same graph. It's a different graph. So the original graph is not even. Then I'm going to ask myself, well, what happens if I rotate it 180 degrees? When I do that, I do not have the same graph, so it's not odd. You can also see that there are different points on here. Okay, they don't match that pattern. Since the graph is not odd or even, it must be neither. We can also test this by picking a point or two on the graph and seeing that they don't follow the criteria for an even or an odd function. Identify even and odd functions from their equations. So is the function odd, even, or neither? I have 2x cubed plus 3x. So I'm going to substitute negative x into this equation. So I get 2 times negative x cubed plus 3 times negative x, and I'm going to simplify it. So I get negative 2x cubed minus 3x. Notice that all of the signs change. So I went from positive to negative, positive to negative. Okay. So next I'm going to ask myself, does it match this pattern of f of x equals negative f of x or f of x equals f of negative x? Yes, it does. It matches f of x equals negative f of x, so the function is odd. So notice that all the signs change from the original function to the new function. This means it's an odd function. For x to the 6 minus 2x squared plus 3, again, I replace x with negative x. I'm getting the exact same function when I replace x with negative x. This means it's an even function. So notice none of the signs change. If all the signs change, it's odd. If none of the signs change, it's even. Okay. 7x to the 5th minus 2x squared plus 4. Again, I replace x with negative x. So I get negative 7x to the 5th minus 2x squared plus 4. Notice I had some signs change, but not all signs change. So this means it's neither even nor odd. Graph transformations of cubic and quartic parent functions. How do transforms graphs compare to the graph of the parent function? So if I have the graph 5x to the 4th minus 2, I'm going to look and see what is different. Okay. I'm going to identify the transformations. In this case, 5 and negative 2. So those are the two things that change from my parent function of x to the 4th. The leading coefficient of 5 stretches the graph vertically, making it narrower than the graph of the parent function. So this is something we actually learned way back in Unit 1 when we were transforming graphs. It's the same idea. Okay, that number out in front tells you it's either a vertical or horizontal stretch or compression. The number on the outside of parentheses tells you if I go up or down. Okay, subtracting 2 translates the graph down 2 units. Okay. Same type of thing with f of x minus 2 cubed minus 1. The parent function is x cubed, so the differences, again, are that 5 out in front, the minus 2 on the inside of the parentheses, and the minus 1 on the outside of the parentheses. So the 5, again, tells me that I'm stretching the graph vertically, making it narrower than the graph of the parent function. The minus 2 tells me I'm translating the graph right 2 units. Or the plus 1, I'm sorry, tells me I'm translating the graph up 1 unit. Identify a transformation. Each of the graphs is a transformation of the parent cubic function or the parent quartic function. How can you determine the equation of the graph? Since the end extend in opposite directions, the end behavior shows that the parent function has odd degree. So it has to be an x cubed, either an x cubed, x to the fifth function. The end behavior indicates a negative leading coefficient. So this graph is a reflection across the x-axis, such as y equals negative x to the third power. The point 0, 0, which is where the parent function normally passes through, has shifted to -2, -1, which shows that the graph has been translated. I translated left 2 units and down 1 unit. Okay, so again, that left 2 units gives me a +2 on the inside of the parentheses, and the down 1 unit tells me to subtract 1 at the end. So the function is y equals negative quantity x plus 2 cubed minus 1. Okay, and we know this is an x cubed or x to the third power instead of just an x function because it's not a linear function. If I had y equals x, it would just be a straight line. So this does have a curve to it, which tells me it's that x cubed function or the cubic function. Okay. So this time I'm looking at a quartic function. So either an even function, I'm looking at x squared or x to the fourth. This has a flatter edge to it, so I'm most likely looking at an x to the fourth. We're also dealing with quartic functions, so it would be an x to the fourth. Okay, and they extend in the same direction, so the end behavior, it has to be even. Degree of y equals x to the fourth. They're both trending downwards, which means it has y equals negative x to the fourth. The point 0, 0, which is where the function would usually pass through, has been shifted to 3. So I went right 2 units and up 3 units. Okay, so again, that's that -2 to the right and that +3 on the end. The other thing that I need to look at, we can see if there's a vertical or horizontal stretch by utilizing one of the points that we have and substituting it into the equation and solving for a. So way back in unit 1, we learned this equation that y equals a times x minus h. It used to be squared because we were dealing with quadratic functions plus k. So that h, again, is that horizontal slide to the left or right, in this case to the right. And the k tells me that I go up or down. That's my vertical. Okay, I'm going to use 2.5 and 1, so 1 for x and 2.5 for y, and I'm going to substitute those values in. 2.5 equals a times 1 minus 2 to the fourth plus 3. 1 minus 2 is -1. -1 to the fourth power is +1. I subtract 3 from both sides, so I get 2.5 minus 3, which is -0.5 equals a. So the equation is y equals -0.5 x minus 2 to the fourth power plus 3. Apply a transformation of a cubic function. The volume of a cube in cubic feet is given by the function v of x equals x cubed. Write a function for the volume of the cube in cubic inches if x is the edge length in feet. So for this, we know that a cube has the same height, length, and width. This means that the volume of the cube is x times x times x, or length times width times height. We know that there are 12 inches in 1 foot, so we can use this information to find the volume in cubic inches by substituting 12x in 4x. So I get 12x cubed. So really what I'm saying is 12 times 12 times 12 times x times x times x gives me 1,728x cubed. Okay, so in cubic inches, I have 1,728 x cubed inches. A terrarium is in the shape of a rectangular prism. The volume of the tank is given by v of x equals x times 3x times x plus 5, or 3x cubed plus 15x squared, where x is measured in feet. The manufacturer wants to compare the volume of this tank with one that has a width 1 foot longer, a height 2 feet longer and a length of 3 feet longer, right? A new function for the volume of this larger unit. Okay, so we can see based on the picture that x plus 5 is the height of the tank, how tall the tank is. 3 of x is the length of the tank, and x is the width of the tank. So using that information, we can add what we want to the width, the height, and the length. So the width originally was x, and now it's x plus 1 because it's 1 foot longer. The height of the tank is x plus 5, and they told us that the height was 2 feet longer, so that's x plus 7. And the length was originally 3x, and now it's 3 feet longer, so 3x plus 3. We can then multiply these because, again, we're finding the volume. So we're going to take the length, our new width, and our new height to solve this. I'm going to use the distributive property. X plus 1 times x plus 7 gives me x squared plus 7x plus 1x plus 7 times 3x plus 3. When I simplify that, the 7x plus x gives me 8x. Okay, and then I multiply that by 3x plus 3, which gives me 3x cubed plus 3x squared plus 24x squared plus 24x plus 21x plus 21. So I'm going to add my x squareds together, and I'm going to add my x's together since they're like terms. So I get 3x cubed plus 27x squared plus 45x plus 21. So that is my new formula for my volume. Summary. Okay. So again, even functions are going in the same direction, either positive or negative. Odd functions are going in opposite directions. Okay. For even functions, my line of symmetry is that y-axis. For odd functions, I have a point of symmetry at the origin, so I'm rotating 180 degrees. Okay, so parent functions for even functions are x squared, x to the 4th, x to the 6th, so on and so forth. So again, they have that even degree, where parent functions for odd functions are x, x cubed, x to the 5th, and so on. So again, they have a degree, an odd degree. If I have something like y equals x squared, I can translate it y equals x minus 4, 4 units to the right, plus 1, 1 unit up. Odd functions, same thing. X plus 4 tells me 4 units to the left, minus 2 tells me 2 units down. And that is the end of lesson 7.